A generator and a battery whose voltages are respectively Vg is equal to 129.6 volts and Vb is equal to 126 volts are connected in parallel through line of superposition. Calculate the current supplied by the generator and the battery and the current taken by the load, the voltage VL and the load power PL. The problem will be solved in 3 steps. In step 1, the battery will be replaced by its internal resistance of 1.2 ohms, and the circuit will be assumed to be energized by the 129.6 volt generator alone. In step 2, the generator will be replaced by its internal resistance of 0.15 ohm, and the circuit will be assumed to be energized by the 126 volt battery alone. In step 3, the separate currents in the various parts of the circuit will be combined algebraically to give the actual values in the composite circuit. The load voltage and power may then be readily determined. So step 1, we have replaced the battery by its internal resistance of 1.2 ohms. By then, we can calculate the total resistance of the whole circuit. Since these two are in series, we add them up to get 4. 4 is now parallel with 6, so 1 over 1/4 plus 1/6 plus 2.85 is in series, so we add that up. Also, the internal resistance of the generator, which is 0.15. So we have the total resistance of 5.4 ohms. Now to get the total current, I is equal to V over R. That is 129.6 over 5.4. And this is equal to 24 amps. Now looking at the circuit, since the generator is supplying power, we assume that the current is flowing from left to right. The total current I1 is equal to 24 amps, and it will split into 2 parts in this node. So the current here in IL will be calculated by 24 times the parallel resistors, 2.8 plus 1.2, which is 4, divided by the total resistances it will split into. So that's 6 plus 2.8 plus 1.2, which is equal to 10. So IL is equal to 9.6 amps. And the current in I2 will be calculated by 24 times the parallel resistor, which is 6, over the total resistances it will be split into, which is 10. Therefore, I2 is equal to 14.4 amps. Now we're done with step 1, moving on to step 2. Replacing the generator with its internal resistance of 0.15 ohm and assuming that the battery is supplying power to the whole circuit alone. So let's calculate the total resistance, starting off by adding these two because they are in series, so we have 3. Now 3 is in parallel with 6 ohms, so 1 over 1/3 plus 1/6 plus 2.8 is in series. Also the internal resistance of the battery, which is 1.2 ohms, a total of 6 ohms. The total current is therefore 126 divided by 6, which is equal to 21 amps. Since we are assuming that the battery is supplying the power, hence the current is flowing from right to left. So 21 amps divides into 2 parts in this node, so that IL is equal to 21 times the parallel resistors, 2.85 plus 0.15, which is 3 ohms, divided by the total resistance it will flow into, so 0.15 plus 2.85 plus 6, which is equal to 9. And so the current will be 7 amps. And I1 will also be calculated by 21 times the parallel 6 ohms, divided again by 9 ohms. Therefore, we have 14 amps. Since now that we have the values, let's compare and calculate for the net current of the two sets. For I1 in the first set, it is entering the node, so we write it as a positive. For the second set, it is leaving the node, so we write it as a negative. So 24 minus 14 is equal to 10 amps. For I2 in the first set, it is leaving the node, so that's negative 14.4. In set 2, it is entering the node, so that's positive 21, a total of 6.6 amps. Lastly, for load current IL, we just simply have to add them together, since the problem asks for the current it is taking. So 9.6 plus 7, a total of 16.6 amps. For letter B, the load voltage is 129.6 minus 10 times 0.15 plus 2.85, a total of 99.6 volts. Lastly, for letter C, the load power PL will be current times voltage. So 16.6 times 99.6 equal to 1653.4 watts.